What's up, YouTubers? So for today, I got a second part to my farmer rod shootout. And by the way, I don't mean any offense when I refer to it as a farmer rod, but that's kind of just welding slang, I guess. It is what it is on that one. So I had previously tested 6011 and 6013, and I know you guys are like, well, what about 7014? So that's what this video is going to be about, 7014. So let's get into it. I apologize if you hear the rain and the snow melt outside. I'm in a tin shed here, so it's pretty loud. Hopefully it doesn't come out that bad on the camera. So what I got today is the Weld E7014, so it's just E-subs, plain Jane 7014. I've ran these before. I've had them in the shop for a while, and I thought, well, you know, I can't cover 6011 and 6013 and not do at least a test with 7014. So we're going to do a simple, quick test where we're going to take this 3/8 plate and we are going to weld 2 fillet welds. I'm going to try and do the best job that I can on both of them. Okay, if there's, you know, porosity or some kind of crater left, it is what it is on that. You know, I'll do the best job I can, and we're going to break one towards the face and then one away from the face, and we're going to see what the actual performance is, and then I'll compare it to other rods like 7018. So with that said, let me get set up and welding here, and let's get these things broke. All right, so I got it all welded up and pretty much burned up the rest of the rods other than this little piece. And I ran a couple just beads on plate just to see kind of how it ran and to, you know, get some practice. I'm rusty with 7014. And one thing I've always found interesting with this rod is it has a tendency to get these little like pock marks along the weld. And part of it is maybe this plate got a little too hot, so that's part of it. But I've noticed that when welding like in the flat position, it seems to do that more so than like a fillet weld. Both of these 2 fillet welds went okay. This one, which was the first one I did, the corner blew out a little bit. It is what it is on that. A little bit of arc blow at the end, and that's simply because I was running a little bit too high of amperage. I ran both these rods at 125, which is on the higher end for this rod, to be honest, even though this is 3/8 plate. What I did for this one, the second one, I crammed it in there a lot more than I'm used to running, and then as you can see, it cleaned it right up. So you definitely want to put some pressure on this rod feeding it in, or it'll get out of control on you. So beyond that, they both look pretty decent, especially this one. I chose to take the better looking of the two to bend away from the face. This guy right here, we're going to bend towards the face, and this stuff's so hot I can feel the heat coming off of it right now. So I'm going to let it cool down, and I will chuck this guy up in the vise over there, and we'll start out with that one. All right, so we're all cooled down here, as you can see. I wouldn't want to do that if it was hot. Being that this is 7014, it doesn't really penetrate that well. So I'll take an educated guess and say this setup is going to break somewhere around 70 foot-pounds. I don't know though. I mean, 6013 was pretty low, and 6011 was, I don't know, a little bit better than 6013. And this is really a test to look at the mechanical strength of it, aka this is more of a penetration test and weld size test more so than it is the actual tensile strength. But let's see where we're at. And it broke at 49 or 50. I'll have to look at the footage. Little on the weak side, but we'll talk about that once we finish up the other bend test. All right, I had to weld up 2 more. I ended up losing the footage on this and got to finish this up, this testing. So I got 2 more welded up, 7014, about 125 amps. these are about the cleanest 7014 welds I've done on this channel. So if we're going to get a pass or fail on this, this is definitely what we're going to, the weld that'll do a pass, I guess. All right, well, let's put it in here and see what's going on. Thanks to the viewer that recommended that I put some kind of lubricant on this. I ended up using some dry lube. I didn't have any spray liquid stuff, but man, this is so much more slippery than it was before. So I don't know why I was an idiot and didn't think of that, but thank you. That should help quite a bit. Not really, it's not going to help something that isn't going to pass, but it will reduce the initial stress of bending it and hopefully stop gouging my plate. All right, let's break this, or well, hopefully bend it. We're definitely in the meat of bending this. We had a pretty significant drop in strength. I don't know if it's broken. And it did. It failed. Not catastrophically in a big kaboom, but it failed. Huh, interesting. Well, I'll set this on a bench and we'll test the next one. So this is equally, I mean, defect-free. This one actually is almost less blown out on the end of this weld than the other one. I mean, for all practical purposes, this is better quality weld than the 7018 weld I used in a previous video. So we'll see if this one also fails. Starting to drop quite a bit. I think it's failed. Yep, and now it just failed. Very interesting. Yep, same as before. Well, let's go to the weld bench and look at what we got. So, we have multiple failures in the same manner. Now, I actually had to redo this part of the video twice. The first time, the audio disappeared, who knows what. The second time, the video disappeared. I had the shop press gauge and no video from my camera. I don't know what happened. So now here I am a few days later retesting this. But hey, at least that rules out the fact that this is going to be a consistent result. I mean, that's 100% the case of what we're dealing with here. So let's talk about what we have here. All of these broke literally in the same manner, okay? They all tore the weld off of the material. So it looks to me like whatever the weld penetrated separated directly from the material, which is interesting. It's hard to say, but it's entirely possible that in all cases the crack or the tear started down here where there was the least amount of weld metal. And on a lot of these, I mean, like you look at this corner isn't even blown out or anything. I mean, that's about as good as you can get at a stop without like a runoff tab or something. If you look at that, still broke. That one broke real close to the edge. This one broke a little bit closer, you know, this way from the end, which again, that's the thinnest part of the weld. Same thing here. As soon as the weld got thick enough, boom, up, and then it tore off the weld. So I would say the consistency here is that the weld itself is going to break off of the plate. Okay, this one is still somewhat attached, but again, you can see weakest point of the weld when stressed is there, and as soon as this weld got, enough tension against it, it just tore the weld off the plate basically. Now, the interesting thing with these results, and I even had someone who kind of left a comment. I don't know what his intentions were, if it was nasty or not, but it doesn't matter because we're here to learn. But he had commented on the 6013, 6011 video where, oh, well, this type of failure is a plate failure and not the weld failure. And he's partially correct in the sense that, yes, the weld failed and arguably maybe the plate failed. But for us, the real reason behind why this failed, I would say almost doesn't matter. And what I mean by that is here's a 7018 weld that was stressed further than any of these. So a further steeper angle, more pressure, and it is still together in one piece. So from my aspect, does it really matter if the plate or the weld is really to blame? If 7018 can surpass the strength, or ER70 MIG can surpass the strength of this rod? And my answer is, well, no. And coinciding with that, all of these are made with the same plate material, the same sizes of plates, cut from the same bar. So all of this is the same material, 100% all prepped the same. The only real difference is the rod I'm using. And to have 4 of these fail, and I have yet to have one in 7018, one in dual shield. I did test a dual shield off camera. That did not fail. An ER70 MIG did not fail, and presumably TIG isn't going to fail either. I haven't tested it. But that, without a shadow of doubt, as far as I'm concerned, proves that 7018 in tension is a stronger weld than 7014. So let's get in a little bit quick on the book smarts of why that may be. So here's a spec sheet for 7014 and 18. If you look in the lower right hand corner, you can see where it says yield strength. The 7014 specs 58,000 minimum and tests at 69,000. The 7018's 58, the same amount, but it actually tests at 71,000, so a little bit higher. Tensile strength 70,000 minimum. 7014 actually tests at 79,000, and if you look at 7018, it tests at 85,000, so massively higher than 7014. And I think that's part of the reason why we're going to see that 7018 passes in this test and 7014 doesn't. Now the Sharpie V-notch, there is no spec for 7014, but it tests at 58, which is actually pretty good. However, that's probably at room temperature. The 7018, where it says -20, that's spec'd for the -1 on the 7018-1, and that tests at 43. So again, interesting numbers. Let's look at A36 steel and the specification on that. So here is the steel that I bought from the supplier. This is what they claim the specs are. And you can see it's 58,000 to 80,000, so a very wide range of tensile strength. The yield strength is particularly low though at 36. What that means is, like you saw in the video where the plate starts bending, but it just doesn't give up. So that's where we're getting that yield strength from, being low, and it actually holds on for quite some time. My particular steel is probably testing closer to the 80,000 mark, because if it was at 58,000, I think that the 6010, 6011, 6013 would have held on and wouldn't have broken. So, I definitely think it's on the higher side, especially because it's 3/8 plate. All right, let's move on. So as expected, this broke. They always break on this. And the results are a little bit lackluster, and that's somewhat, I guess, what I expected. So this broke at sub 50, which is very similar to the 6013 weld. And the primary reason behind that is that 7014 really doesn't have much penetration. And anytime you bend something towards the face of a weld, if there isn't penetration, you're going to have far poorer numbers. And if you look here, pretty typical, somewhat of a lack of fusion at the start of the rod. I did have hot start enabled, but my machine that I was running on is either on or off. You can't adjust it, so this is very typical. Now, when you get back to over here, there's no evidence that the original plate edge was even fused. You can see the original plate edge there. So no root fusion, which is exactly what I expected with 7014. And the issue with not having root fusion is that on a single weld like this, with no root fusion, what ends up happening is the weld, when you stress the weld towards the face, the plate can lift up off. And the further in the penetration is, the more you end up having to tear the weld that's internally there, and it takes a lot more force. And that's why like 6010, 6011, even short circuit MIG in this test did better than this particular rod. I've also tested, and I'll mention it now, running higher amperage, and you know what I found is that, like with this particular rod, running more amperage doesn't mean more penetration. Running a bigger rod would likely get you more penetration at the correct amperage, but running like an 1/8 inch rod, it's not going to bite in more with 10 more amps. And I was already running this at 125. I seriously doubt that, 140 would have made much difference in this test, and it would have blown the corner out even more. Which, speaking of that, when you look here, the corner isn't really filled that well, and it did fuse down to the edge of the plate, same thing with the start, but if that was even a little bit better, this weld would have performed better. So this ultimately was a little weak. Pretty expected. Let's look at where I broke away from the face on this guy. So the interesting thing is this on this one is it actually appears to have tore the plate clean off the weld. And if you look at the backside of this weld, you can see that whole line there's like a gap under there. That's because the plate tore off, and you're not seeing the weld that fused that. The plate failed. All of these welds that I've been doing in this testing series has been cut off the same bar stock, so I don't think it's like, oh, this had a weaker, piece of bar stock, because they're all the same piece. I think what could have happened here is simply, by the look of it, I mean, maybe, it's hard to say though on the top. There was no undercut that I could see. I mean, I definitely picked the better of the two welds, and it is favoring a 45-degree angle, so that's correct. In this case, it's hard to say. I mean, it could have been a change where the weld metal met the base plate, and that change was more brittle than the base plate. It's possible, because if you look here, so here's a 7018, and let me zoom out for you. When you look at how much of an angle these both were bent at, all right, I couldn't get the camera angle to show right before, so I moved it. This back plate is a 7014, this is a 7018. You can see, so it broke here, right about right here, how much more angle was put on this 7018 plate, and it's still, I mean, I gave up because at this point, you can see what happened. I was just bending this plate and these two together, and it wouldn't fail at this point. So what did we learn today? Well, I learned that 7014 under tension in this test is not as strong as 7018. And this video is a great example why welding is far more complex than just a couple of simple numbers. Oh, well, 7014 is as strong as 7018. Is it? Well, no, I would definitely say no. 7014 is as strong as ER70 MIG wire. I would definitely say no. And this isn't to bash 7014, because I believe that it is a stronger rod than 6010, depending on what you're doing. It also is, you can run it on pretty much any welder, and it works great on real thin material because its penetration profile is pretty thin. So there's a lot of benefits to 7014, especially if you're new at welding. It's a lot easier to run and restart and all of that than your typical 7018 is. But as we saw today, the performance of it is a little bit lackluster. And now I'm going to put a couple things out there like I do in most of my videos. Let's be honest. Will 7014 fail with something you're welding? Probably not. This is a test that puts a lot of force on this weld, and in the case of these, I believe we saw somewhere around 8 to 10,000 pounds. Now, granted, not all of that was on the weld, but we're talking at least 4,000 pounds hanging off of this at this point, okay, of pressure trying to split these. So that's a tremendous, I mean, that's, you know, 2/3 of my pickup truck resting on this. So that is a tremendous amount of force. And guess what? This happened to break, and 7018 ER70 MIG doesn't. Will that affect what you're welding? Well, if you put a lot of stress on it, yeah. My recommendation would be if you can run 7018, it's smarter to run it and not substitute 7014 for it. The other thing I'm going to mention, I've mentioned this in a lot of other videos, a lot of guys run 7014 to avoid the storage requirements of 7018. The issue with that is 7018, the storage requirements are so that it meets the low hydrogen specification, so you can weld high strength steel without what's called hydrogen embrittlement. Well, 7014 has no storage requirements, but that's only because it's not a low hydrogen rod, nor will it ever be, and nor should it ever be used to weld high strength steel. So what I'm trying to say is 7014, if you compare 7018 to it and you take a rod that was improperly stored with 7018, it will not put any more hydrogen into something than 7014 will. It'll still likely put less because a lot of the rods have moisture resistant coatings, okay? So from that standpoint, that's not really a good excuse to use 7014 over 7018 because the storage requirements are primarily to give you the ability to weld high strength steel, something this can't do properly. So don't be afraid of 7018 because of storage requirements over and think you're okay with 7014. You go weld some AR500 plate on a tractor with 7014 and come back and tell me how the weld cracked clean off of it under stress. So that's something interesting. Now, this is not a direct result of hydrogen embrittlement. I can tell you that, and the reason is A36 mild steel is not susceptible to that really. So these failures are not related to that. And besides, the rod I welded this with had been sitting on a shop floor, I think, for quite a while, or definitely improperly stored. But yeah, and it really, I guess the gist of all of this, what I'm trying to tell you is not shitting on 7014. If it works for you and you haven't had failures and you're not using it in things that require absolute strength, great, good for you. If you can run a good bead, great. If you need strength, learn to run 7018. It's the clear winner here. There's no doubt in my mind. So with that said, if you got any comments, questions, concerns, you know where to leave them. I know this is a little bit controversial of a topic, but I mean, the results speak for themselves. And if you think I did something wrong in the testing that led to this, then tell me and I'll fix it. But you know, I think I could run this 100 times and have the same exact failure. And I could do this 100 times and maybe one out of them would break, and it'd probably be because I wasn't paying attention and laid down a terrible weld. So anyways, thanks for sticking around for the video. Hopefully you learned something. Until next time.